Hi there fellas. Tonight I want to talk to you about homework, which is on page 185. I expect you to be able to complete all problems on page 185, and I'm just going to give you a couple examples of how to go about it. This one's more like question 2. There's 4 questions on that page, but if you can do question 2, I think you can do the lot of them. So pay attention to this one. Pause whenever you like. So our job here is to graph this linear equation, y equals 2x minus 1. Y equals 2x minus 1. And we're going to do that by, there are other techniques that you'll learn about in year 9 and 10, but today we're going to do it by establishing a table of values. Here's a table of values that needs to be completed, and then we're going to simply plot them on a number line here, which I'm moving around at the moment, on a number plane I should say. Okay, so now here's the thing. Our rule says that y is 2 lots of whatever x is, subtract 1. Y is 2 lots of whatever x is, here are your x values here, minus 1. So you can probably see that when x is negative 3, the value of y is going to be 2 lots of that, so it's negative 6. Take away another 1 is going to give you negative 7. Okay, and we just fill in our table of values along those lines. So for the next one, when x is negative 2, when x is negative 2, y is going to equal 2 lots of that, so 2 times negative 2 is negative 4. Take away another 1 is negative 5. And so we keep going. So when x is negative 1, negative 1 times 2 is negative 2. Take away another 1 is negative 3. Do you notice what's happening here? We seem to be increasing by 2 every time. Negative 7, negative 5, negative 3. Negative 1 would be a reasonable guess for here, wouldn't it? And then 1, positive 1. Then 3, and then 5. Okay? Now, you'll notice a connection here between the amount of increase there, it's going up by 2 every time, and the coefficient of x. And what this is saying is it will go up, the values of y will go up by 2 every time, as long as your x values are going up by 1 every time, and they are, and as long as y is a subject of your equation. So that can be quite a quick way of completing your table of values. And now all we need to do is complete the plot. So let's expand it. Good, we can go up like that. So when x is negative 3, y is 7. So let's put a plot point there. So we do the x first, remember? So we go to where x is negative 3, it's there, and go down to negative 7. So that's a bit awkward, isn't it? But it's about here, I think, you'll find. Okay, and negative 2, negative 5 is there. I've already drawn the line in, so I'm cheating a bit, but these plot points should fall on that line. Negative 1, negative 3, so that will be there. So that'll be negative 3 there, in fact. In the same way, this is negative 7. And 0, negative 3 is there. Sorry, 0, negative 1, I should say. And then 1, 1 is there. And 2, 3 is there. So it really should be a 3 on that axis. And 3, 5 is there. Okay, that's how you plot those. All right. Let's have a look at this one. Y equals 4 minus x. Okay, so I've got my x values there, and I've just got to simply substitute the x values into my equation, and I shouldn't have too many problems. Okay, now just to give you a bit of a tip, see that negative x there? The coefficient of x is negative 1. That means, you know, there's an invisible 1 there, right there. And that means that as long as my x values are increasing by 1 every time, my y values will be decreasing, because it's negative, by 1 every time, just to let you know. Okay, so that can make life a bit easier. Alright, let's turn to our table now. Y equals 4 minus x. So when x is negative 3, what's y going to equal? Well, it's going to equal 4 minus negative 3. So 4 minus negative 3 is positive 7, isn't it? Okay, now I'm expecting the next value to go down by 1 every time, but let's just be careful. What happens when x is negative 2? So 4 minus negative 2 is positive 6. So yes, it has gone down by 1 that time, and we can expect that to be the case for subsequent values. Remember, that handy trick is only valid, the handy trick of using the coefficient of x, in this case it's negative 1, when my values of x are increasing by 1 every time. Okay, so now we're going down by 1 every time for the y values, aren't we? 4, 3, 2, 1. Let's just check out to make sure we haven't made a mistake the last one here. So when y is 3, we're saying that, when x is 3, y should equal 4 minus 3 is 1, and that seems to be correct. Okay, so let's plot our results. And I've got a little graph here that we can use. Okay, so what did we say? When x is negative 3, so it's a bit hard to see this, but negative 3 is there. X is 7, that would be my first plot point there. Negative 2, 6, remember you always do the x first, so x is negative 2, and y is 6, so that goes there. Negative 1, 5, so negative 1, 5, that would be 5 right there. 0, 4, the y-intercept, by the way, is 0, 4. 1, 3 is there. 2, 2 is there. And 3, 1 is there. Now, when I ask you to do these plots, you won't be given the line. You've got to draw these dots, plot these coordinates, because that's what these table of values are, is a set of coordinates, and just simply then draw a line through it. Okay, so that's tonight's homework, page 185. You have a go at all those problems. Thank you.